Okay, Matt 1140, these are the chapter 7.1 notes. There's a lot of terminology on this first page. Want to make sure that we are comfortable when we throw out these words. Okay, so a term is anything separated by a plus or minus. So it's a variable multiplied by a number, or it's a constant. So this is a term, the 2x, the 4y is a term, and the minus 9. We take the operator in front with it because there is a positive 2x and a positive 4y. We kind of ignore those pluses. We definitely need to keep in mind the negatives. So down here, we're going to skip one for a minute. Coefficient. The coefficient is the number part that we attach to a variable. It counts how many of the variables that we have. The constant term is the number part with no variable. And like terms, which we don't have up here, are anything that are the same. So here are like terms. We've got an example, the 2m and the 6m. Those are like terms. As well, the 3xy and the 7xy. The number out front may be different, but the variable part is exactly the same. Last term here we need to consider is factor. A lot of times it's helpful to be able to break something into smaller pieces. It makes it easier to work with. Okay. So this first question is, what's the difference between an expression and an equation? An expression is kind of a collection of terms. Separated by pluses or minuses. We simplify an expression. We evaluate. That is different than an equation. An equation always has an equal sign. And here we're going to be asked to solve. Find the number that when we replace it in terms of into the variable, we make a true statement. Okay. So example 1, we first want to make sure we know how to verify if something's true. When it's all numbers, that's pretty 8. We're going to multiply 4 times 7. We get 28. 28 definitely equals 28. That one's good. B, order of operations says we go left to right. So the 3 plus 4 is 7. 7 minus 7 is 0. So that one's good as well. Example 2 wants us to identify the terms. Again, anything separated by a plus or a minus. So here our terms are the 7 and the C. In B, we have the 7xy, we have the 3x, minus 4, and this piece right here is all considered a single term. I am multiplying a coefficient by some variable. So the 2x, 2 times the quantity x plus y, that is a single term. So here we've got 7xy, 3x, negative 4, and then the 2 times the quantity x plus y. In C, this 4x divided by 7, that is a single term. That is x times 4/7. And then the positive 5. So anything separated by a plus or a minus is going to be a term. Example 3, identify the coefficient of each term. Now the coefficient is the number part that counts the variable. And so I've included a couple of specific ones here. A, negative xyz. Just like we don't write a 1 in front every time we have a variable. So if you take a look at example 4, this x here, that's 1x. We know by looking at it, I've got an x, I've got 1x. When we have a negative out front, this means negative 1. Negative 1 times xyz. When we've got a fraction, notice I don't have anything in the numerator being multiplied by the x. That's the same as 1 times x. The x can be in the numerator. It can be pulled out separately, so our coefficient here is 1/2. And then c, it doesn't really matter how big or ugly that number is. Whatever number is in front of our variable, that's our coefficient. Okay, now, as we go to solve, we are going to use mathematical operations that keep the equation true. So we're going to think of this as being balanced, and the x plus 4 on the left-hand side, whatever it is, it has to equal what's on the right-hand side, which is 11. In order to keep it balanced, if I choose to do something on one side, I have to do that on the other side. So what I'm going to choose to do is make a 0 over here. I've got plus 4, I'm going to subtract 4. Because plus 4 minus 4 is 0. I just have x over here. 11 minus 4 is 7. On B, x over 3 we read as x divided by 3. The opposite of divide by 3 is times 3. And when I say I'm multiplying by 3, I'm multiplying by 3 over 1. 3 over 3 is 1. That is not what we are doing. Multiplying by 3 over 1, so I have a 3 in the numerator and a 3 in the denominator to cancel. I get 1x left over. 12 times 3 is 36. Sometimes, like on C, we have more than one operation. So again here, I'm going to add 5. Just to make sure I'm doing the same thing on both sides, I'm including these two lines. I'm left with 3x equals 21. We're going to divide both sides by 3, and x equals 7. Now, how do we check this? I can take this value. It's always a good idea to check. What I've done is I've created different equations that are equivalent to what I started with. But if I take a look at that last equation, it's pretty obvious that x has to be 7. So if I go back up to my equation and I want to check, I'm going to plug it in and see what happens. I just said x was 7, so I'm plugging in 7 for x. I get 21 minus 5, which equals 16. That's what it's supposed to be, so this works. Sometimes we've got equations and we want to write them as sentences. Plus 4, a lot of times you'll see as 4 more. 4 more than x. And I don't know what x is, but I know if I add 4 to it, I get 7. 4 more than x is 7. A lot of times you'll see the word is for the equal sign. B, 3 times x. I'm going to write it that way. 3 times a number, because we don't know what it is, plus 1, or it could do what I just did over there, 1 more than 3 times a number, is 7. Again, that equal is our is. We can also go back the other direction. 4 times the difference of a number and 3. So I'm starting with this one. The difference of a number and 3. Difference means I'm subtracting. I want 4 times that. So I'm going to subtract first and then multiply by 4. Again, I have the is 12 part. The b here, 7 more than twice a number. Oops, sorry about that. I'm starting with twice a number, 2 times x. 7 more than that, plus 7 is 21. And then some practice at the bottom here, just simplifying. So I've got 3a minus 7a. We go left to right. I'm counting a's. This is negative 4a plus 1a. I haven't done anything with that a at the end. I get negative 3a. 5x minus 3y plus 2x plus y. I can only combine things that are the same. So I am going to move these around so my x's are together and my y's are together. Notice this negative in front of the 3y goes with it. I got 5x plus 2x, which is 7x, minus 3y plus y minus 2y. I cannot combine the x's and the y's because those represent something different. We don't always have to do that. You can. Sometimes we can just pay attention to what we're adding. A lot of times when we work with variables, we do want to list them in alphabetical order. It just makes it easy to compare if we're comparing to somebody else. D, using the distributive property. This 5 out front means I have 5 of these mystery 2x minus 4s. I don't necessarily want to write 2x minus 4 5 times, so we shorthand and we multiply. We know this 2x happens 5 times, that's 10x, and we know this negative 4 always also happens 5 times, that's minus 20. And we have to be really careful on E. We see that 4 plus 3 and then the parentheses, and we want to add 4 plus 3, but we cannot. Order of operations says we multiply first. So this 4 plus waits out here. I've got 6x plus 9. Now I can combine the whole number parts and I get 13 plus 6x. The last one we want to pay attention to is the understanding that when I am subtracting a whole set of parentheses, that minus applies to everything. So this is 5 minus 2a minus 3b minus 7. We want to be very careful and make sure we don't ignore that double negative, because minus a negative means we are adding the opposite, and we want to acknowledge that there with that 3b. Now I've got 2 constant terms. I got this 5 minus 7. Where we put the constant doesn't really matter. A lot of times we like putting it at the end. So both of these are perfectly fine. They say the same thing.